Hey, hey, hey. Okay, so we did not have the opportunity to finish problem number 74. So please pull it out. I rewrote it so it could be a little bit more legible and made a few adjustments, but we'll see. So please take a moment to think about, well, to look at the scenario. Okay, so remember as we look at our 4 steps, here we know we have to determine our HO and our HA. So we're seeing that it's going to be greater than or equal to 1. We're talking about the conductivity of a certain type of glass. We know it's a 1 sample t-test for mu. And the only reason I'm putting that there is because you guys are really getting confused between mu and p, etc. Okay, as we look at our the definition of what mu is, so it's mu is the true mean conductivity for this or a particular or a certain type of glass. So as we look at step 2, as we look at the sin part, so we have 11 randomly selected pieces of glass. We have our independence, all pieces of glass being greater than, all pieces of type being greater than or equal to 10 times the sample we have. Okay, now here we got to look at normality, and as we look at our box plot, we see some skewness. My box plot is kind of wonky, so let me straighten this up. And remember, this is on a modified box plot, and I see some. It looks heavily skewed to me. So heavy skewness or heavily skewed, given such a small sample size. And that's why I said we need to proceed with caution. But if we did this on a box plot, and I just taped the box plot from the book, here is your dot plot, etc. I'm sorry, your dot plot, and it doesn't look that skewed. So remember how I've told you before, I really can't stand box plots. Sometimes they're so deceptive. I think if I use my normal probability plot, it would be better. So I guess note to self, if you have time, try more than one. But I do want to say definitely use the modified box plot to check for outliers. Which takes us to our 3rd step. Our 3rd step, please remember, this is in our calculator. And we use the data. Well, let me get my calculator so I can remind you of how this worked. Okay, so I have my information in my L1. Kindle, I hope this is better. So now I'm going to press stat, go over to test, the t-test, press enter. Okay, I have it's going to be my data. My mu sub 0 is the same as what I have right here. It's going to be 1. I have it in my L1. And I don't mess with the rest of this. The frequency, I don't care. And we can see that it's greater than, again, based on that right there. Okay, so calculate. So here we see I have my test statistic. I have my p-value 2.1 times 10 to the negative 6. I have my mean, and I have my standard deviation, both of the mean and standard deviations for the sample. And remember, it's a t-test because I was not given sigma. Now I take all those values and I plug them in. That is not supposed to be there, that dot. Okay, it finally worked. Okay, and you get the p-value, as we said, even via your calculator, 8.95. The degree of freedom was going to be 10, 11 minus 1. Here's your p-value per my calculator. So with all of that, our final conclusion, which is our step 4, with a p-value that's less than alpha, and here it's essentially 0. we're going to reject DHO, which means we're going to support or fail to reject DHA. So there's evidence to suggest that the true mean conductivity of the glass, I should have said, is greater than 1. So that's problem number 74. Now I want to do problem number 73. Next time I see you, I want to do the second part of problem 74, the type 1 and the type 2 error, because we know we have issues with that. So I'm going to wait. Okay, here is our problem number 73. You see it has a little play button. I almost started not to do it. It's like, why am I doing this if they already did it? But, you know, you can look at both. Go ahead and look at the scenario and also put all of this stuff in your L. I have it in my L2, but put it in your calculator. Now, we need to recognize when we know to do a hypothesis test or a test of significance. So you can see as I've underlined there in the red, whenever you see, is there convincing evidence? That tells you HT is coming, a hypothesis test is coming. Okay, we also see here I have a random sample of 10 drivers. And here it has also that our mean of that particular sample. Well, nope, I don't have that. I've got to find it. But that the mean that they are comparing everything to in the construction zone is 25 miles per hour. So let's get started. Our step 1 is that mu is going to equal 25 miles per hour. That's our HO or HA is going to be greater than 25 miles per hour. Because the question says, is there convincing evidence that the average speed of the drivers in the construction zone is greater than the posted speed? Where the true mean is the speed of all drivers in the construction zone. And yes, I'm doing a one sample T test from mu. Next, as we look at our SINs, I've got my conditions and assumptions. So looking at the first two, they're the easy ones. I've got 10 randomly selected drivers. Independence is 10 times 10, because remember the sample size is 10, is less than all drivers in a construction zone. Now as I look at normality, remember I'm looking at either histogram, box whisker plot, normal probability plot, or a dot plot to make a determination. So here's my box plot, the modified box plot, which shows that there are no outliers, but it shows that it's skewed, and that thing looks heavily skewed to me. Okay, but when I look at the idea of my dot plot, which I just ripped off out of the book, it doesn't show, it shows us a very slight skewness, but it still confirms that there are no outliers. That might look like an outlier, okay, but you know you can use the outlier formula to confirm. So you can see how both of these methods are kind of problematic, but 21 is not that far from 25, so I wouldn't say it's an outlier. Okay, but remember, if you use this drawing and you said it was skewed heavily, which it looks like it, you're just going to do it and then say proceed with caution. But if you do it with this and you see a slight skewness and it's no outlier and you do have a small sample size of 10, we're like, okay, I can still use the T procedure. So let's make a note of this. Okay, to use T procedure. And because of all of the SINs have been looked at, it's okay to continue with the test procedure. So okay to use my t-test. Okay, now finally to the math. Here, I know that here is my naked formula. But as I look at my naked formula, let's go to our calculator to see how this goes in. Okay, so let me get out of that. Let me clear. So I'm going to go over the stat. over the test. It's a t-test. Now, if I remember correctly, I think I put my data in my L2. We'll find out in a minute. Okay, here the frequency state, we don't touch that. Here, yes, is greater than. Remember, because that is your HA. Go down. Okay. I think I don't know what's in my L, so I need to redo this. Oh, I know what happened, and I'm sure some of you guys noticed it, because there was nothing wrong with my list. However, what did I not change? I forgot to change my mu, because remember, the mu is based on whatever my HO is, which should be 25. So now, there we go. That is a heck of a lot more reasonable. So as we see right here, I've got it's confirming that my HA was greater than. I've got my test statistic. I've got my p-value. I've got my mean for the sample of 10. I've got my standard deviation for the sample of 10, and this just confirms it is 10. So I just take everything, plug it in. I mean, literally plug the numbers in. Here, plug in what the output of your T is. Here, write down what my p-value is. And then after that, I know my degree of freedom is nothing but be a 9. So that means I'm going to reject the HO. So given a p-value that is less than my alpha level, I am going to, and here are the values of 0.0069, and which is less than 0.05. I'm going to reject the HO, which means I'm going to fail to reject the HA. Therefore, there is convincing evidence to suggest that the true speed of all drivers in construction zones is greater than 25 miles per hour. Now, when I say there's convincing evidence to suggest, remember we talked about our box plot versus our dot plot. With this heavy skewness, there's no convincing. You got to proceed with caution. But if you use this right here, it's slightly skewed, so since it's slightly skewed, you can say that it's convincing. But nevertheless, just continue to do the process and support your reasoning. So the type 1, type 2 error question, we are going to wait till we're together. Have a great weekend. Bye-bye.